Magrid nan amahle, sanwanan dumelam. Let us solve problems which have got to do with the geometry of the straight line. On the board, we are given an instruction which says determine the values of the variables. We are also given a diagram with all the representation. Now, we need to be able to apply our basics as far as the geometry of the straight line is concerned. We need to be able to interpret information which is represented diagrammatically. As you can see, line segment BC is parallel to line segment DE, and line segment DC is the traversal of the two parallel line segments. Okay, we are required to determine the values of the variables. So in this case, we have got three variables. The first one is X, there is Y, the last one is Z. These are the three variables whose values we need to determine. Let's start with that one. As you can see, given the fact that BC is parallel to DE, we can tell that the angle over there is equal to the angle over there. So we'll say x plus 10 degrees is equal to 3x minus 40 degrees. The reason these two angles are corresponding angles. Why? Because line segment BC is parallel to line segment DE. That is the first step. From there we solve accordingly. Everything that has got x in it should move to one side, and everything else that doesn't have x in it should move to the other side. So bringing 3x to this side, it becomes negative, and taking 10 to the other side, it becomes negative. So we're going to get negative 10 degrees minus 40 degrees. So this minus that will give us negative 2x. This minus that will give us negative 50 degrees. Dividing throughout by negative 2, we're going to get this. Divided by negative 2 is the same as that, divided by negative 2. So here we get x. Negative 50 degrees divided by negative 2 will give us 25 degrees. So we've got the value of x. We move on to the next variable, which is y. So in this case, I suppose you can see that this angle is equal to the angle over here. So I'm going to say 2y plus 30 degrees is equal to 5y minus 90 degrees. The reason is that these two angles are actually alternate angles. Why are they alternate angles? Because line segment BC is parallel to line segment DE. From there we have to make sure that we take everything that's got y in it to the one side, and everything else that doesn't have y in it has to be taken to the other side. So we've got 2y minus 5y. Taking this to the other side, it becomes negative. We get negative 30 degrees minus 90 degrees. 2y minus 5y will give us negative 3y. Negative 30 minus 90 will give us negative 120 degrees. From there we divide throughout by negative 3. Negative 3, negative 3. This into that goes once, so we're left with y. Negative 3 into negative 120 degrees will give us 40 degrees. We also have the value of y. Now we move on to the last variable, which is z. Now that we've got the values of x and y, we can look at those three angles. This one, the one over there, as well as that one. The sum of these 1, 2, 3 angles should be 180 degrees. So we're going to say z plus 2y plus 30 degrees plus x plus 10 degrees. The sum of these triangles is 180 degrees. So the reason will be that their sum of angles on a straight line. So we substitute the known variables in there. We're going to get z plus 2 by 40 degrees plus 30 degrees plus 25 degrees plus 10 degrees. The total is 180. So z plus 2 by 40 will be 80 degrees. 30 plus that will give us 55 plus that, 65 degrees. 180, z plus 80 plus that will give us 45 degrees being equal to 180 degrees. Z should be equal to 180 degrees minus 145 degrees. I suppose you are still following. Finally, we subtract 145 degrees from 180 degrees to get 35 degrees. Hooray! We have managed to determine all the three variables in that diagram, x, y, and z. Thank you very much for your attention. For more information that will assist you in your studies, please subscribe to our YouTube channel at PP Maths and Science Lab. Thank you very much.